Hello. Welcome to 9 Questions to Build Great Infrastructure Pipelines. I'm your host, Rob Hirschfeld, and I am excited to be presenting to you for SREcon21. This is actually Chapter 3 of my Infrastructure as Code automation series, and I strongly recommend if you're interested in bare metal automation, check out my first chapter from a year ago, my second chapter from Lisa of 21, where we talked about infrastructure as code and challenges in physical infrastructure. What we're going to talk about today is generalized infrastructure lessons. And these are hard lessons that RackN has been learning over the last 7 years, and even before that from our founders' careers in data centers going back 2 decades. And we have the experience of working with companies deploying global fleets at massive scale. And this isn't consulting, it's not a SaaS, these are really helping customers do the work themselves, own the work, and stay in control of their own infrastructure. And to do that, we've always started with why. Why is it so much that automation is never enough? That we keep writing custom automation, and that when we do, the automation we write ages so badly. And we never actually know if we've done it right or wrong. These are things that we're doing pretty well in development, but in automation and building automation, it doesn't feel like we've really gotten there yet. And that is really what RackN spends a lot of time asking ourselves. Why has it been so hard? Why are we making so little progress in building real systemic automation? And the answer keeps coming back to complexity. We have built environments that seem to be antithetical to building good automation. They are complex and siloed, and the tools we have only work within the span of one layer or one application set. And this isn't even the scope of the problem, because we have added layers on top of layers and used different tools at each one of those layers. And while it's okay that we've done this, it hasn't created what we really want to have, which is automation that works smoothly across all of these layers, what we're starting to call automation pipelines, which are similar to CI/CD pipelines, but for infrastructure and automation. And we're going to talk about the questions that we have been asking as we build this type of automation, as we look at end-to-end automation and really making things work. And what we found is that infrastructure pipelines and the concept of having a connected infrastructure is really important here. And these are the questions that we've been asking ourselves as we look at finally designing automation at the system level, as we really work to take automation that is connected in a sequence of operations. It's modular with state and configuration and process all working together, something that can actually lift customers end to end and deliver a working solution from the first boot or the first install or even before that, all the way through to a delivered system. And that doesn't necessarily mean in one tool. It means that we've been able to connect things together, just like a CI/CD pipeline connects things together. So these 9 questions can really help you understand the challenge that we have and some of the answers that we've been finding as we go. The first is, why doesn't my CI/CD pipeline understand infrastructure? And that's in some ways the simplest. The CI/CD pipeline, which in itself is a relatively new concept, right? We used to just have build systems. When we look at a CI/CD pipeline, it's designed to flow artifacts. I build code, I test code, I check code, I deploy code, I move it in a linear direction from the source code all the way through that system. Infrastructure is fundamentally different. Infrastructure is a resource model. It's about consuming resources, and the state of those resources are absolutely critical to understanding how the whole system works. We have to understand the environmental constraints, the life cycle, how configuration drifts, how things join and drain. And some of those we've sort of fudged into CI/CD pipelines, but we've lost the resource context and systems. And the biggest thing for us about this is it's about having a continuous cycle process. Resources, especially in physical resources, are persistent. Even in cloud resources, there's a lot of things that are persistent within the cycle. It's not just an immutable one-direction process. And so when we think about that, we have to ask ourselves, so why is pipeline flow different than other orchestration? The pipelines that we're building really focus on a destination. They go linearly from raw materials to finished goods or finished systems, and they are relatively linear. They're designed to be used over and over again and understand that we're dealing with resources that are persistent, but they are pretty linear systems. Orchestration, on the other hand, tends to be trying to figure out where you're going to go, an if-then map, with a lot of branches and things like that. When we've looked at the pipelines that RackN has built, they do have dynamic elements where they say, oh, this is one type of hardware or one type of cloud or one operating system or another, and they respond to what the resource constraints are. But they're pretty simple. You're solving for, I need a resource done here. What type is it? Let me abstract out that change and then move through a standard set of processes. You never get surprised by what happened at the end of the day or have somebody come in and add some extra steps that change the outcome of your pipeline. The pipeline's outcome is predictable. And that really brings us back to the intent of the pipeline and why we are so focused on having these predictable outcomes, right? Why focus on intents instead of chained actions like an orchestration would be? And the reason we do that is because the intent, the outcome of the pipeline, is really our abstraction boundary. The goal inside the pipeline is to hide the complexity of the types and the constraints and the prerequisites and all that stuff. We don't want people to have to worry about that. We want to have automation that handles it, sure, but when you are interacting with a pipeline, you want to say, I need you to get this resource, this code, to this destination. And the pipeline handles it. You don't worry about what goes on inside of it. And that provides an incredibly powerful abstraction interface. Because then as you integrate into the pipelines, and pipelines are designed to be integration points, they're not meant to be manual knob turning, build my pipelines and manage them. They're automation APIs. When you do that, then you can focus on the outcome. Then you can focus on, I need a machine that has Kubernetes ready to go, or I need a machine that can join into a Kubernetes cluster. That becomes the source of your system. And you shouldn't care if it's on hardware or a cloud or a VM or anything. You want to be able to influence what that is, perhaps, right? There's inputs and configuration state that go into building a pipeline. But at the end of the day, you ask for the outcome, not all the things that are in the middle. And the less you worry about what's going on inside the middle of your pipeline, the more resilient and abstracted your automation is going to be. And this removes us from saying, I need a VM, or I need a machine, or I need a container. We're actually talking about outcomes. And it's a very powerful way to think about how the system should work. And in that, as we look at what has to happen inside of the pipeline, we have to be asking ourselves, why are provisioning and configuration so different? We hit this one a lot at RackN because as we take a system all the way from end to end, what we found is there are times when we have to do configuration, working inside the system. Think of an Ansible or Chef or a Puppet, where we're actually making modifications and hardening a system and installing applications and doing configuration. It's very different than the provisioning operations we do, like Pixie booting or network install or installing an image or using Terraform. Those are provisioning operations that happen outside of the context of the system that we're ultimately going to be doing. But when we really ask this question, we think about the different types of automation that we build. And that isn't just provisioning and configuration, but it includes monitoring and data collection. It includes cluster coordination as we coordinate between different systems, which are different, right? We're actually building clusters, interacting with the cluster control plane outside of either the machine provisioning or its configuration. And what we've seen is that for each type of operational context, we have to be able to move things around. And as we got better at moving the operational context of alternating between different types of automation, we actually found that our automation, our pipelines, constantly changed the context. That there were times when we had to do all four types of this automation together in one step or one segment or right back to back. And that as we were able to switch types of automation within the pipeline instead of stacking them and doing only one and then only another, things became much, much easier to control and manage. It really was rethinking what the pipeline would be versus what the individual tools that we had to deal with are. And where that comes up is really this frustration. So once we realized that we had to use a lot of tools together in parallel, we got very frustrated asking ourselves, why can't I share state between tools? And wow, it becomes really, really important to be able to think through that state sharing is essential in building a pipeline. A pipeline is really building a progressive state as a system, as a resource is transformed. But most of the operations tools we use are built from the bottom up. They excel in their context, but they're not really good at sharing state with other systems. Right? And the challenge becomes that they've assumed that they have a single source of truth, that they know what's going to happen, and they control the resource over the entire span when that tool is active. Think of a Terraform state file or an Ansible inventory file. And they're designed to work within their tool, but not share information. The thing that we found when we build pipelines is that the pipelines are required to standardize the way they share and synchronize state. That our ability to pass state and requirements and template information and inputs and then retrieve outputs from tools and then connect them together is really what made the pipeline a distinctive concept. It's very similar to what we see with the CI/CD pipeline, where the sum of the parts becomes much more powerful than the individuals. One of the ways that we made this work is that we kept the tools that were good at what they were doing into very narrow constraints. So using a tool in its strong suits, where you can tell it exactly what you want it to do, have it execute, and then get the output, makes them much more powerful. And in that case, you can narrow their necessity to be a source of truth, and then share that information more readily across different pipeline layers. Whew! I'm going at a mile a minute because there are a lot of questions that we had. So pausing for a second to reflect, maybe think about pina coladas or whatever your favorite pineapple is, but we are over halfway there. So hang in there, we're cruising. Our next question, why can't we just ignore what is between the pipeline flows? So if your head's getting around this idea that we've gotten a pipeline that takes a resource from one state to another in a very predictable, intent-driven way, that sounds great. But 99% of the time that you have with a resource is not in the pipeline state. The pipeline is a transition agent. But once the system has reached that stable state, you still need to be able to automate and control and manage that system as a service. And one of the big lessons that we have in asking this question is that it's not enough to say, I'm going to transform resources and transform resources. When RackN just focused on that part of the equation, it was very frustrating for our customers and our users and operators because they wanted to take actions that weren't transformational. They just wanted to do service or check-ins or monitoring actions. It's very important that you recognize that even as you build these pipelines and automate them, that once you're done, the resource still is an automatable unit, that it's going to have to be able to take automation and run as a service and be in a service mode, what we're calling a work order mode, where you can submit work orders, have them processed, versus having a pipeline where things are actually being transformed. Now, we do run transforms over and over again. That's an important part of pipelines, but the idea that they flip modes was an important lesson for us and a rethinking of how we actually look at the automation that we send into our pipelines and to our resources. The next thing that we started asking ourselves, and you've heard me talk quite a bit about this, is why is infrastructure as code so central to infrastructure pipelines? And infrastructure as code is misunderstood in a lot of ways. I spend a lot of time expanding the scope of infrastructure as code beyond but it's in Git. My infrastructure is code now. We really need to think beyond that, because infrastructure as code and the ability to do code-like libraries and common automation and reuse is critical to what we're building. The way we've been thinking about this, and this is something that I have to credit Daryl Plummer from Gartner on, is this idea of building codes, of thinking through how you get information and automation to be like a building code and a standard, where things are going to fit together, that we have COTS components and they connect and we know things are safe. So think about being able to plug plumbing together or electrical outlets as you're building a house. The fact that those are standards that we can count on, interconnects that we can count on, really drives innovation. It eliminates safety concerns and security risks and things like that. We need to think about how our infrastructure as code drives building codes for the cloud and for infrastructure. And those standards, that interconnection, becomes what makes a pipeline, not the end-to-end piece, but the fact that it's composed of segments that we can actually connect and stitch together. And so that is a really important question for us. So we know that we should be decomposing pipelines, but why is it so hard to reuse and share these automation points? And the infrastructure as code helps quite a bit, but critical realization here is that we have to isolate universal repeatable parts, things like laying down an application or setting up a configuration file, apart from the things that are custom, what your security standards are, callbacks into your inventory system, or your specific credentialing needs. There are things that are standard and things that are unique, and we're not trying to say don't do those things. What we're trying to say is the standard parts have to be clearly in standard parts of the pipelines, and the other parts, the interconnect parts of the pipelines, have to be built in a way that they allow you to extend them for handling bespoke needs, because everybody does have bespoke needs. So what we've found is that standard pre and post operations allow us to decouple the site specific from the common, right? We do things like callback and classify, validate, ad hoc tasks. The ability to take a standard pipeline segment and customize it using configuration rather than automation is actually proven to be essential to being able to reuse these standard pipeline segments. And that leads us to our last question, which isn't even a why question. It's what is holding us back from doing this work? In DevOps culture, we are taught over and over again that we have to work across the silos to avoid technical debt. But then we're only helping ourselves. What we really need to do is think about open source community efforts and external collaborations that maintain systems. That takes extra work, but we need to be able to do it. We have to be able to do shared and curated processes, and that means that you have to be willing to do the work to ingest those, and you have to do the work to improve or contribute back to them. That really is what's keeping us from making this work. So I've been flying through this material. There's a lot of questions, a lot of thoughtful things, and a lot of lessons that RackN has learned that I've sped through. And we'd love to talk to you more about it. I do want to show you how we are doing it in very specific terms so that you can see that these processes are adoptable, that you can do similar things and learn from our experience here. When we build infrastructure pipelines, we actually have infrastructure as code contexts around building these pipelines. And a pipeline for us ends up starting with some configuration and then walks through various workflows. The workflows are things like discovery, burn-in, hardware conformance, OS installation, and app install. Each one is its own workflow, and they get chained together in a predictable way. The thing that makes this powerful is that inside of each one of those segments, they are actually very, very similar. They all have standard pre-processing work. They all have standard post-processing work and ends in a chain so that you can connect things together, which means that you can use your hardware config unit wherever you have hardware, or in any application, you can pull in the appropriate segments and build custom pipelines. The segments remain the same and reusable. And then within each segment, we have places where you can have customization that allows the site-specific work, adding ad hoc tasks, doing classification to make sure the systems look right, or figure out what exactly they should be doing and making some interpretation, and then validating the system. And validation is different for different customers and different sites, or different use cases. All those things have to be considered and then incorporated into these standard processes. And that has to happen both at the beginning and at the end of the segment. And that allows people to have a known good way to build pipelines, build their own segments, add their own pieces in. And that has been really the secret to making these infrastructure pipelines standardized so that anybody can use and reuse the work, so that we don't keep reinventing hardware installation or Terraform provisioning operations or Ansible integrations. All of those things are done in standard ways so that they can be connected together easily and then maintained in the community. So let's do a little bit of demo This is Digital Rebar 4.7, and what I'm showing you here is the universal workflows, what make up our pipeline segments. So in this case, there are pre-staged components. Generally, we start from Universal Discover, and then the systems know how to chain into different systems, such as hardware, image deploy, Linux install, burn-in, bootstrapping. And the way you put these together, they all have standard starts and standard outs with the standard pre-configured systems, is by assigning a profile into these systems. So if I was to look at the universal profiles, spell it right, and pick a Universal CentOS 8 application. Here what it's going to see is it's going to tell me what operating system I want to install and which system chain of the pipeline that I want to work, in this case a Linux install pipeline. This allows us to drive the pipeline through a sequence of events and dynamically change it as we need to, or define it all up front, which is exactly what I've done with one of my systems here. So I have a standard machine. This is running as a virtual machine on my desktop. I'm going to start up several more. And I've already decided that I want this one to become a universal application Rocky 8. So it has Rocky 8, uses the exact same pipeline that I would use for CentOS. And we're going to go ahead and go through that process. Now I'm just going to start the machines. I already have them queued up. And what you'll see is that this first machine that I have running is going to go through a normal boot process. So are the other ones that I have booting. They're going to all go through the exact same discovery process that I have in the system. And that's a hallmark of how pipelines are implemented. We can be confident that they will run through this standard process. Now, one thing that you will notice here is that I've already got this one machine. I've set that Rocky 8 profile. So this system will go through the normal discovery process, realize that it already has a profile and a pipeline assigned, and begin to execute that pipeline process. I'm going to keep that on top so that we can look at it and watch how the system goes. But you'll see it go through that automated process here. And you'll also see updates live as the systems go through. So if we were to look at machine 4 over here, it's being discovered and it's running through a standard process, and we will see that the components go. But because there's no pipeline assigned yet, it will just do the discovery work and then stop. And you can see all of them running through, going through that process and making things go. This one does need to have a pipeline assigned, so I will go ahead and do that. And it will run through and begin the install process as soon as it confirms that the system is where it should be. For these other systems, if I want to assign them to different pipelines, all I have to do is assign a profile. So if I want this one to be Ubuntu, I can pick my Ubuntu universal pipeline. Here we go. Assign it, and then restart or start the pipeline, which will begin that machine through the process. Or, in this case, since it hasn't actually finished the work that it's doing, it's going to immediately identify at the end of that discovery step that it should become a Linux system. This is exactly what a classification step would do, where the system could identify that it needs to become a certain pipeline, and the classification would allow you to inject whatever pipeline you wanted. These systems over here have not finished, or have finished, and so I can go in and I can make some other choices. I could set this one to be Rocky. I can try at least. That one's now Rocky, and this one could be CentOS. Here's my Universal CentOS 8. And assign that one. And for these, all I have to do now is allow them to start the universal workflow. So as soon as I start it, they will then go through that process. If I check in on some of these other machines, what you'll see here is this one's already beginning its Ubuntu install. Machine 1 is busy doing a Rocky install. Machine 5 over here is going through the universal workflow pieces to make that work. And the idea that we have completely standardized these processes so that regardless of what I'm going to install, I'm going through the same sequence of operations means that we can then take these sequences and apply them to cloud infrastructure, different hardware types, different operating systems. The amount of consistency and repeatability that the pipelines have enabled is really breathtaking, because we can do something as simple as change a profile on a system and then have it become something new. And that process is reusable, modularized, and very repeatable. Hope this gives you an idea with very simple views of just how powerful it is to be able to take a system, set a target configuration profile on it, and then allow the pipelines to be the abstraction point for your infrastructure more generally. So let's reflect a little bit on all of these pieces together and maybe take them out of the question format and give you some practical things to do. First is modularize your automation, then standardize your interconnects and share state between layers. These things really make big wins as you can go from automating components or abstractions into building pipelines. To do that well, you're going to have to be able to mix configuration, provisioning, monitoring, and orchestration. Think through how you want to do it. You don't have to do all of them at once, but every little step you do towards making yourself more resilient means that you're using your tools better and you're minimizing the footprint and state that you're going to have to deal with. And finally, never assume that abstractions mean layers are decoupled. One of the lessons that we have as we build these pipelines is that coupling adds complexity. And to an extent, you can only avoid it a little bit. So we recommend thinking through very carefully how the systems are going to be built, look at where your coupling points are, and build out the correct abstractions and the correct layers. Thank you for listening to this presentation. I hope the questions are helpful and that the insights, these hard-won insights, save you time in building resilient automation, building your own pipelines, and really being proud of the infrastructure and the way you're managing it and running it for everything. We are sponsors of SREcon21, and we really do want to have conversations about this. So please come by and say hi, ask questions about how we build pipelines, and if you are looking for help in making these types of improvements in your own infrastructure, we want to hear what your thoughts are and what we got right and what we got wrong. Thanks a lot. This is Rob Hirschfeld. Have a great conference.